He's joining by any chance?
He's also joining, he said. You are audible clearly, Avinash.
Who?
Avinash.
Avinash, is it audible and the screen is visible?
Am I audible?
Yeah. Yes.
Welcome once again. We will probably give about 30 seconds before we start. Good afternoon. Welcome to yet another Smart Kid and Musings, which is a gentle, flurry, and interesting thoughts. And today is a part one or a two-part triptych or duology, if you like it, which is titled Deep Assurance. And the part one is Deep Hypothesis, the art or the science and art of seeing the invisible. So this diptych is primarily about looking at the notion of depth, two of them. The depth of how to deeply hypothesize, and the second, how to deeply probe. So the first one, as you can see, is titled as Deep Hypothesis, Seeing the Invisible, and the next week is titled as Deep Probing, which is Touching the Unknown. So it's a two-part musing on deep assurance. So before we get into the content, let's take a second to look at what do we mean by saying depth and where does it come from. Depth is not about action. It really begins or starts in awareness. It is really an act of beginning by pausing, where then we start seeing, noticing the quality and the not doing. And awareness really is a very active perception, right? It's like the stillness before the insight. It's observing a subtle shift. It's kind of noticing where the coherence, the thing that holds together, kind of weakens. It's really the listening before the acting and perceiving the balance before the proof. And then, of course, recognizing the imbalance, the potential imbalance before it manifests. And this stillness really is what sharpens perception and prepares us to form a clear hypothesis. And therefore, the awareness really is the foundation, so to speak, of intelligent assurance. And with that said, we will probably go into looking at the part one, which is about hypothesis. And we'll do it in a slightly different style today. We'll do it in a kind of a seeker-muse conversation, where my colleague will probably as a seeker, play the role of a seeker of trying to look at questions, and I will try to be musing on that, so to speak. Hopefully a slightly different way of presenting a possibly very abstract and deep topic.
Okay, so can you tell us about defect hypothesis? Why imagine what might go wrong before anything even begins?
So why do we have to hypothesize? Why can't we just get on to doing, right? And that's what we do. Testing really confirms what we believe, and that's what we do. It's an activity more often. But what we're talking about is hypothesis, which is basically about coming up with questions of what we might miss. We're giving ourselves a set of objectives, setting ourselves some kind of a goal, figuring out a potential plan. Therefore, hypothesis really is a bridge between the perception and the final proof, where the curiosity that we have, a fundamental trait of a good tester, is turned into clarity, which is what testing is all about. Like testing checks and hypothesis explores. It's about asking what if before the system answers what is. And this expands the awareness from a confirmation to a discovery process. We know that. And therefore, it's all about anticipating the imbalance, the incoherence, before it appears. Sensing where what we're attempting to do by pure logic, implementing logic, may become illogical. Therefore, it's really about shifting from a reactive correction to a proactive comprehension.
Okay, so you right now spoke about defect hypothesis. From that, something stayed with me. That is the sense of listening before proof. If hypothesis begins as awareness, how do we recognize that early stirring? How do we notice the quiet imbalance before it turns into noise? These thoughts shift how I see testing. It's no longer feels like checking correctness, but sensing coherence. I start asking smaller, earlier questions. Not is it working, but is it holding together?
Truly an interesting thought for sure. I guess that's where we begin. Because the awareness notices this imbalance. But what we need is a form. And that's where a hypothesis gives it a form. And so when we talk about deep hypothesis, we're trying to figure out if there is a way by which this fleeting intuition becomes a structure. That vague unease that we have as curious testers turns into precise inquiry. That perception, that intuition crystallizes into some meaningful geometry where that my private sensing, so to speak, becomes a shared understanding to us all. Right? And that's where the thought gains form and becomes collaborative, sparking one insight to another. And fields, whereas hypotheses, frames, and form lets us see others what you sensed. And the shared structure is what turns the intuition, a personal intuition, into a repeatable intelligence.
Okay, so that makes me wonder, once awareness opens up, how do we give it a shape? How does a faint feeling become strong that we can share and act on?
So now it's probably time for us to delve deeper and look at it from an idea of geometry. Are there various elements, various aspects that we can keep in mind when we do this so that we can give the thinking a form? And maybe one way to look at it is the elements that form the geometry of the hypothesis. Is there one? There isn't a one. There are probably many of them. This is one thought. Maybe the elements that we are probably going to cover and examine and run a few examples to probably illustrate and appreciate are these. The element of code where there are known facts and there are imagined possibilities and how we bridge them. the idea of boundaries, where there is an exploration and where we stretch it, it kind of dissolves, breaks. The element of plane, looking at it from causal angle, from a temporal angle, from a structural angle, from an experience angle, and so on. The element of a vector, the fourth element, so to speak, where we are kind of figuring out a reasoning through prediction or reflection or exploration. And finally, the last element of symmetry, which is kind of like the core, but not exactly core, which is a balance between the fertile imagination and the real evidence. We will, of course, see that in greater detail as we go. But all I wanted to kind of muse about is to kind of give the contour by saying, hey, there is possibly is a structure, and there may be 5 elements like these.
Such an interesting thought, but as you said, that good hypothesis has a geometry. What does structure look like when we think about systems or defects? How can we trace its outline without overcomplicating it?
Fair enough. Now that we have got into the notion of abstract, we will onion peel the abstract layer a little bit, give it a little bit of an example as we go. Remember, what are we trying to talk about? We're talking about how we are trying to lend a form to the thought. And therefore, each of these axes is like a coordinate of thinking. Like we briefly mentioned about each of these, which I'm going to highlight as we go in the next few minutes, is where we're looking at a core, which is where there is a known fact. It is what is and what might be. That kind of a thought. What I know is and what I think may be or might be. The second kind of an axis or a coordinate of thinking is really the boundary, where I'm trying to explain, if you will, where it explains everything or nothing that continue. And the other one is perspectives. And what perspectives of thinking, I'm looking at it from a time perspective, a cause-effect perspective, or an internal structural perspective, or a large systemic perspective, or the user experience perspective, and so on. Right? So each of these are in some sense axis, a coordinate of thinking. And when we get into the last one, which is about symmetry, it's really about where is imagination? Are we getting into fantasy? Are we doing something possibly bordering on illogical curiosity, right? And so on and so on. I will give you certainly some examples. Just to start off with one, we will talk on each of these as an example. So remember what we're trying to talk about is the deep hypothesis geometry. So when we say core, and then we say we're known facts, what do we mean? Let's give it a little, flesh and blood. Let's say I'm doing some payment and the intent is, I have to probably do a payment, right? So that's the intent. And there is a system state. And then its system state ultimately gets into a notion of completion. So the hypothesis is, could there be a temporary loss of a state that breaks this intent? And what could it be? And therefore, is it handled well? Right? And that for core kind of becomes like an anchor. It is an axis of connection. It is the what and the where of potential imbalance. A centered relationship hypothesis is built on between the intent and the core. How could the coherence break? Right? And that's what we're trying to get at. It's a system of thought. It's not an answer. It's a particular axis, right? So what are we trying to do? We're saying, hey, this is what I want. This is my intent. How can I figure out the imagined possibilities and drill it down with the other axis as we go? So if I step into the next one, which is about boundaries, and extend this example. And we say, yeah, it can fail, because now I'm going to look at it from a boundary perspective. Maybe there is a lot of low, maybe there is a lot of spiky, maybe there is a bit of a slowness, and therefore there is a timeout. So I'm kind of looking at it from a stretch perspective. That's at the boundary. We're trying to look at boundaries as in terms of load. We're trying to look at it from a gateway perspective of a credit card or a wallet or an API or any of these forms of payment. And we're looking at a time window which might be very short, maybe it has to be done within a few seconds. So we're trying to look at what are the boundaries that might impinge and therefore cause, and then trying to look at the hypothesis and then find out if this could be possible. And therefore, we try to make the hypothesis a little more testable, measurable, boundary. Because without a boundary, we can't really test, right? So we're trying to find out, based on some of the ideas of core, going further, the limits of applicability using boundary amount of scope, right? And that's the other axis that helps us to do. Going further down, I can probably continue on the thought process by saying, okay, it fails to peak load. So now we can look at it from different. Why? Why might it fail? How is it built? When does it happen? So I can ask these questions from the notion of these various planes, the cause and effect, the way it is built. From a perspective of time, it happens only in the end of day, or when everybody is trying to settle the transactions, for example. Or maybe we look at it not from the system, but we look at it from the user's experience, right? And therefore we say, hey, it's too slow, or, I can't accept it. And finally, of course, looking at it in a larger system, because not all our code is our code. We do rely on a lot of other things. So each plane, in some sense, exposes a different layer of causality, multiple perspectives, and it's a multi-dimensional map. Continuing on the same idea, we said it's time out, and then we're asking from a perspective of forward, backward, inward, outward. If it is a cause, why? Is it because of latency? What could be the sequence of operations? So you see, now we're trying to use these dimensions of thought to develop a more cleaner hypothesis, which is deeper and becomes testable, right? And that is where we are moving ahead with this idea. Deep hypothesis is a part of this stuff. And vectors give us a direction of thought, gives us a direction of inquiry. And finally, of course, being sure that we're not stretching ourselves and become starting to think of fantasy. Like, for example, servo timeout may cause, but you don't want to go off and say maybe aliens are affecting it. Right? So you want to be sure that you're not stretching your imagination so crazily that it is sometimes incorrect. But of course, remember, it is curiosity. So curiosity could go all the way to aliens, right? So we are trying to keep an open-minded curiosity and a balance with the factual grounding. And therefore, hypothesis in some sense becomes like a structured imagination, right? So that's where we are trying to look. If I were to summarize it in a dense kind of slide, not that I'm going to read it out. I just want to summarize it by saying, yeah, there are 5 axes. There is an essence in terms of what these 5 axes are: reasoning, inquiry, thinking layers, reasoning directions, and finally the balance. And each of them have a certain focus and a help in how they occur, right? So in summary, these 5 axes is about the center of reasoning, the edge of inquiry, the layers of thought, the directions of reasoning, and finally closing it with a balance. That was probably a deep conversation.
That was such an interesting thought. Now, as you have described these facets of core, boundaries, planes, vector, symmetry, I begin to see thinking as design work. Now, how can I use this structure when reviewing something as small as a user story or as complex as an architecture map?
Now we get to the definition, to, in some sense, trying to illustrate with examples, and the most important question: how do I apply? How do I apply this defect hypothesis geometry? And remember, we are like the question was about how do I do it earlier, maybe on a spec, maybe on the larger system of architecture, right? And that's what we're trying to do. So we're trying to look at, before we commence the act of testing, before we commence the act of inquiry and validation of the system, we're trying to imagine. And so when we talk about imagining, we're framing it as a defect hypothesis exercise. It's not a root cause analyze exercise. We're asking what could break and why before it does, right? And that's where these ideas, the axis of thought of core and boundary, etc., allows us to imagine in a meaningfully structured fashion and not go haywire, right? It turns the act of prediction into a disciplined imagination, right? So it's like saying, how do I know what could be the user and where could user intent and the fail system be out of sync? Under what conditions, right? So when you take a user story, you try to ask these questions. Where could the intent and system fall out of sync? What conditions might this hypothesis hold or collapse? Could things like load or timing or behavior integration distort the actual flow of action of the spec? How might we reason from a forward way, from a backward way, from an inward way, from an outward way, etc.? And how do we balance this imaginative exploration with a known evidence? So in sum and substance, when you talked about user story, the architecture, really asking how do we question to possibly imagine what could go wrong? And that's what this is all about, right? So it is a defect hypothesis exercise, and we are trying to look at it from these 5 elements or 5 axes of thought, which explore a variety of different things, and hopefully not get too way off and too confused in the entire process.
Okay, so now can you walk us through one situation where these paths meet? How a small shift is reasoning exposes a larger risk. This way of looking feels different, slower, more deliberate. Quality seems less about doing more and more about seeing earlier, connecting dots before they drift apart. And how do we learn to see those dots before they actually drift?
Yeah, that's a great thought. I think they've always probably looked at smart QA as doing less and accomplishing more. It's not about doing more, right? And therefore, it is about seeing more in the mind's eye before they happen and hopefully try to prevent or preempt. So it's about seeing relationships. It is not reactions, where we are moving to a notion of a spatial thinking by using depth, right? So if you look at the left, the picture, which is kind of a bunch of dots connected, deeply connected, maybe like a neural network, so to speak. We are trying to take a particular focus on a center part and see how they all connect, how they all perturb the other things, right? So if you're saying, hey, if I say, look, I had some logic, maybe a retry logic or a payment retry logic, and I did something to improve the throughput, so that I can be handling more transactions. Now the question is, how do I know what I did could affect, right? Maybe it's a change, maybe it could be a new feature that I added, whatever. So all we're trying to say is we're trying to look at it from how could it perturb? So whether it's a new one or an existing one, what we know is I need to know if that individual works fine and that individual does not affect any others. When I say individual, I mean possibly a feature and the corresponding flows, right? So when you say a retry logic is changed, we're looking at it as here is a timing glitch, becomes a design flaw when it sees through some layers. You say, hey, this could affect that, that could affect this, and so on. So, or when UI tweak, maybe I decided to add something that we can select from instead of typing. And like once I saw, somebody did a little query and populated that list box, which happened to be a few thousand elements. And now when you click, it takes probably quite a few seconds to drop down. I don't think that person thought about it, right? It's very easy to fix, but it was, looks in hindsight stupid, right? It took a lot of time to figure out why the system's performance suddenly dropped. All they did was a UI tweak of connecting and making a new list box, so to speak, from choose or drop down. It affected the entire stuff. Or you add some new field and suddenly you forget the fact that it causes trust issues. It breaks security sometimes, right? So could be as simple as a UI tweak, which is visible, or some internal system where I tweak the system actually ripples across the entire system. So some kind of an assumption distorts the global behavior. And that's what we're trying to look at and constantly ask, how could it, and therefore find out, does it break the coherence? Does it expose an imbalance? Does it reveal some hidden dependencies, right? And so we are kind of looking at it to figure it out, and all we're trying to do is to hypothesize. And that's when these 5 planes, maybe 5 elements, they form the geometry, may possibly work. And that's what probably is part of a methodology which I think we'll take it as we go. But remember, depth is not detail, it's a perspective, right? It's seeing interdependence is what we want. It's not about going deep and then getting lost and spending a lot of time. It is about ability to see the detail and the connections, right? And that's what is important. And that is where HyBIST as a methodology comes in, which translates this depth into a discipline practice, right? Where we look at it from various layers of data-related issues, interface-related issues, behavior issues, integration issues. So we classify issues and then asking how can each of these layers pose its own issues which use coherence. So we're trying to layer the fact of uncovering of defects into saying there are different kinds of issues, and therefore we are trying to lend a structure, a framework of depth that transforms this awareness into an assurance, making the casual seeing to a systematic understanding, right? Remember, HyBIST as a framework, as a methodology, does not replace intuition. It, in some sense, lends a certain discipline. It is like saying there is depth plus a structure, is sustained clarity, right? So in a way, it's like if I apply the same retry logic example, at the behavioral layer, it looks fine, but at the system layer, it's trained the integration. At the business layer, it impacted trust. And that's what we want to kind of be able to discern, right? And that's where a methodology, the HyBIST, hypothesis-based immersive session testing, could be of use.
Yeah, now I understand that. So it means that when we think in depth, we start seeing relationships instead of reactions. But how do we train that wider view to notice how one small design choice can ripple through behavior, experience, and value?
Well, I briefly talked about the methodology, and maybe the methodology is an aid. Methodology is actually a system of thinking, right? And that's what it is. And that's why we turn this entire business of philosophy, so to speak, into some practice. So HyBIST really is a personal methodology, a system of practice. And like as you mentioned, it kind of decomposes that entire problem of finding defects into many layers, broadly speaking, which are put down as 6 broad layers at the same. That is, issues related to data, interface, and so on. So when you ask the question, how do I do it? It's like saying every layer, you kind of move from every layer, asking some questions and figuring out some answers. Could be as simple as starting from, am I clear about the lowest layer and how does it connect to the highest level? So it starts from the basic input clarity to the outcome of business value, where we're not seeing depth as in terms of distance. We are trying to see as clarity and interdependence, right? It's organizing the thinking. Hopefully in some way making that blindness a little more visible. And that is where probably the methodology can aid. And one part of the methodology is about hypothesis, which is what we probably talked about in greater detail, because hypothesis-based immersive session testing is what it is. And in today's musing, we're primarily talking about the first part. The next week's musing, we'll talk about the second part, which is the immersive session testing, which is really an act of probing, right? And what we're trying to do is it helps us to focus the intuition. It does not replace it ever.
Right, got it. So now, like Gen AI is in the picture. So how can Gen AI genuinely help us think and sense more deeply to reveal gaps and drifts we might otherwise overlook?
Yeah, that's a nice question, simply because of the fact that now we have intelligence today from the system. So the question is, can we harness that intelligence? If I have these 5 ways, 5 aspects of by the elements which form the geometry, so to speak. If I could use that, where could Gen AI extend? How could it extend our depth? How could it help us surface some patterns? How could it help us figure out certain drifts in the meaning and semantics and highlight some risks? So remember, all we were trying to do is to form a systematic, meaningful questioning mechanism to preempt issues, and then convert some of these into potential real evidences with probes. Right? And so what we're saying is, hey, if I could come up with these questions, can I find some answers? Can I post these questions and get better questions, and therefore amplify my thinking? And so all I'm trying to do is, could Gen AI amplify this awareness? Maybe. I guess it's powerful enough to do that. I use it as an assistant. Right? And where does what we talked about fit in? The ability to systematically do it so that we don't get lost by asking random questions, it giving us nice and interesting and sometimes hallucinating answers, and then we get lost in the entire chain. So I guess our intuition, coupled with the perception of the machine, which today is reasonably intelligent, extends our depth. Right? And that's why I think there is an interesting promise of AI. Our eye that you see here, with the, so to speak, the machine's neurons, so to speak, is what the picture kind of highlights. It's that interesting fusion. It's probably an interesting time for us to see how we can capitalize on the new technology. But as in any technology, it's only a brilliant assistance.
Such a wonderful thought. If deep hypothesis is that art of seeing before doing, and what mindset should we carry forward so that awareness, structure, and empathy becomes a part of everyday assurance, it all comes together.
Yeah, we talked about a lot, not from how to do, we talked about really is about the what and the depth, and then thinking. So the question is pretty apt, as it's largely related to the mindset and the thinking. And as we talked about, we said depth is not about just analysis. It's not about an activity. It is not about just in terms of how far. It is about attention. We started with the notion of silence, listening, observance. And that requires us to see before doing, to sense before testing, to turn the awareness into a quiet art of assurance, which today is complicated because quietness is not something that we have today. It's a very busy world, and you've got a lot of interruptions. Right? And one of the most interesting books that I did read is the book called Deep Work. I think it's written by a gentleman called Cal, I forget the last name. But rather it simply says deep work is essential, especially in these terms. And that requires slowing down. Slowing down in terms of focusing the mind, right? And that is where it is. So how can I do it? It's not just sitting in a corner and meditating. It is about meaningfully applying some well-formed thinking techniques, one of which is what we talked about from context of hypothesis, to see the coherence. And therefore we start listening, and therefore sensing better. Right? And that is where depth truly lives. So in a nutshell, I guess we got to slow down to be faster. Thank you so much.
Thank you.